All right, so we're still at 6.1, still in section 6.1, and I'm gonna do some more of those examples, right, where we're evaluating some stuff. So we did a few of these already. So part E. Oh, let's see if we can do tangent inverse of tangent of pi over 3. Now I know what you might be thinking. You might be thinking, well, at the beginning of the video we said, or at the beginning of the lecture we said, the idea behind an inverse is that it's trying to undo what the original function does. So if we're doing tangent inverse of tangent, well, those should just cancel each other off, and we should just get pi over 3. And in this case, you're right, but that's not always how it turns out. So I'll give you an example, but let's maybe be a little more careful. Let's tread lightly here. So let's actually just evaluate this thing, right? So tangent of pi over 3, tangent of pi over 3. So at pi over 3, sine of pi over 3 would be root 3 over 2, right? So this is root 3 over 2 over 1/2. So I think we're just going to get root 3, right? So we get tangent inverse of root 3. Okay. And now we can think, okay, so tangent inverse of root 3. It has to be an angle. For tangent, the restriction is that the angle has to live between negative pi over 2 and pi over 2. Okay. So for tangent inverse of root 3, we should be looking for an angle between negative pi over 2 and pi over 2, such that tangent of that angle is equal to square root of 3. Well, it must be the pi over 3 from the previous part, right? So we must get pi over 3 here as our final answer. But now contrast that with this one. Okay, let's do tangent inverse of tangent of 2 pi over 3. Tangent inverse of tangent of 2 pi over 3. We are not going to get 2 pi over 3 as our answer. Okay, and some of you may see why already, but let's just work through this the same way we worked through the previous one, right? So in this case, we'd be looking for tangent inverse. Tangent 2 pi over 3. Well, tangent, this puts us in quadrant 2, right? Tangent's going to be negative in quadrant 2. So I think we're going to get a negative root 3. Right, the reference angle is still pi over 3, so it's just the negative version of that angle. We get tangent of negative root 3. Well, so now we have to think, okay, so I want to do tangent inverse of negative root 3. So I'm looking for an angle such that tangent of that angle is negative root 3. Of course, 2 pi over 3 would do the trick, except that our angle has to live between negative pi over 2 and pi over 2. And this is bigger than pi over 2. Right? So this one's not going to work. Okay. In fact, we need to be in quadrant 4. We need to be in quadrant 4. So definitely, it's going to have a reference angle that matches this one. Okay, but it needs to be in quadrant 4. In fact, it needs to be in the negative quadrant 4, right? So it needs to be between negative pi over 2 and 0. So I think actually the answer we're going to end up with is negative pi over 3. Okay, so negative pi over 3. Tangent of negative pi over 3 would definitely be negative root 3. Okay. And negative pi over 3 is between negative pi over 2 and 0. So this is the one that does the trick. So notice that in this case, tangent inverse of tangent, they didn't just cancel off and give us 2 pi over 3. We ended up with a completely different angle there, right? And that goes back to what we were saying when we started this lecture. These quote-unquote inverse trig functions are not true inverses because the trig functions themselves are not one-to-one, right? So consequently, if you're starting with an angle that's sort of outside of the standard domain, then and then you find the trig function, then take the inverse, you're going to end up back inside of the standard domain, which means this angle is not going to be the same. It's going to be a different angle than what you started with. Something else I'll mention is that this is only an issue when you have trig inverse of trig. If you have trig of trig inverse, then they will cancel each other off every single time. Okay, and we'll write this down in a second. Anyway, so that's the idea there. So you have to be a little careful about this kind of issue. Let me give you another couple examples. So let's say we wanted to do arcsine -1. Again, arcsine is the same thing as sine inverse. This is exactly the same thing as sine inverse. It's just another way to write it down. We'd be looking for an angle such that sine of that angle is equal to -1. And the angle needs to be between -π/2 and π/2. So if you were thinking, 3π/2, right? Because sine is equal to -1 at 3π/2. Well, you're correct, right? Sine of 3π/2 is -1, but the angle we're looking for has to live between -π/2 and π/2. So instead of saying 3π/2, we're actually going to say, let me draw it out, right? If you were thinking this angle, you're almost correct. The only problem is that our answer needs to live between π/2 and -π/2. Okay, so we do want this angle down here, but we can't call it 3π/2. We need to call it -π/2, right? So arcsine of -1 would be -π/2. Okay. Another thing to be careful of is if you are asked some kind of question like this, arcsine of -2, well, then you know it's nonsense right off the bat, right? Because you'd be looking for an angle such that sine of that angle is -2. Impossible, right? Sine lives between -1 and 1. So this thing is undefined, right? No such angle exists, okay? You can verify that all of these answers are correct by using your calculator. And since all of this portion of the course is online, there's no way for me to really know if you're using your calculator or not. But I think it's worthwhile to go through the mental exercise of trying to work this out in your brain so that you get a really good solid grasp on what's going on here with all of this inverse stuff. But ultimately, it's like you're going to have to use your calculator for some of these things, because for some of these things you don't have the values memorized, right? So, for example, so let's use a calculator to evaluate the following things. So let's do arc. Whoops. We'll do arc cosine 0.7. Okay, so the one thing you'll have to be careful of here is to make sure that you're in the correct mode, right? Degree mode, radian mode, and all of that. In this section, they'll switch back and forth between degree mode and radian mode and everything. But let's figure out arc cosine of 0.7. Let's give our answer in radians, since that's what we've been working with so far. Oh, my calculator's in degrees. I should have said degrees. I'll change the mode. Radians. Okay, let's go to radians. So I'm going to say, I'm going to find a little cosine on my calculator. And I know I told you couldn't use graphing calculators in this class, but on my calculator, it's in green. It's right there, that button in green. So I'm going to press diamond, cosine inverse, and then 0.7. Okay, so that's approximately 0.7954. Okay, and that's all there is to that. If we were doing something like arc secant 0.7, well, now you might have to do a little bit more work. Because you probably don't have a secant inverse button on your calculator, right? So this is where you kind of have to say, where you kind of have to realize that secant is 1 over cosine, right? So we have to be careful about this. How did we write this out before? So arc. So this is not the same thing. It's not the same thing as 1 over arc cosine of 0.7. Okay, it is the same thing. It is the same thing as arc cosine of 1 over 0.7. Okay, so just be careful that you're not taking the reciprocal of the entire thing. You just take the reciprocal of that number right there. Okay, we've talked about this in the past. Okay, cosine inverse 1 over 0.7. Oh, non-real result. Of course, we should have known. Oh, I should give you a different example then. Well, okay, my calculator said non-real result. The reason it's telling us it's a non-real result is because secant lives between negative infinity and negative 1, and it skips over from negative 1 to 1, and then it goes from 1 to infinity. So you're not going to get a value for secant inverse of 0.7. If we change it to 1.7, see, there I go making this mistake and not like realizing it right away. But anyway, if we change it to 1.7, there we go. So we get, that's about 0.9419. And that's how you take care of those things, okay? All right, I'm going to start another video.